Hi, hello, welcome to my lecture series. I am Kalpana from Aerospace, and today in this series, in this video, we'll look about the vertical speed indicator. In past, we are looking on the flight instruments. So, in this regard, we will see the vertical speed indicator, how it is works, and how it the mechanism works like that, and its applications. So VSI, the vertical speed indicator we used to call VSI, it's sometimes called as VVI, vertical velocity indicator. Whether it shows, it is the uttermost thing whether the aircraft is in climbing, descending, or in level flight. So which means yawing moment. So climbing, descending, or in level flight. If the rate of climb or descent is indicated in feet per minute. So if probably calibrated, the VSI indicates a zero level flight. So the VSI, which is sometimes called a VVI, velocity vertical velocity indicator, it's indicated a feet per minute, probably calibrated. And then next, in this slide, diagram, you can clearly see the mechanism of vertical speed indicator, how it works. It is nothing but also a barometric. It's a basic barometric instrument which is we improved like sensors nowadays. So here it's a it is working with a static connection. We have seen pitot and static. So by using the static connection, it works. So when the static port of the aircraft where it is located, descending or ascending or in steady flight like that, so it gives the pressure here in this piston. So in this dashpot piston, when it moves, it gives some pressure to the diaphragm. So when the diaphragm moves or varies in pressure, the indicator gets moved by the gear, the basic mechanism of gear mechanism. So here we can see the restricted passage because the error will not occur in the indication of the VSI. So it is operates solely from static pressure only. It is differential pressure instrument, and it contains a diaphragm like a connecting linkage you can see, and gearing the indicator pointer inside the airtight case. The inside of the diaphragm connected directly to the static line of the pitot static system. We already mentioned. Can you remember the pitot tube, which is located on the in front or steady of the flight, wings of the flight. So the area outside the diaphragm, which is inside the instrument case, is also connected to the static line, but with an restricted orifice meter to eliminate the calibration leak. So both diaphragm and the case receive air from the static line at the existing atmospheric pressure. The diaphragm receives the unrestricted air. So while the case receives a static pressure. When the aircraft is on ground level or in level flight means in 0 degree, it's moving on means flight. The pressures inside the diaphragm and the instrument case are equal, and the pointer on the indicator shows the 0 indication. So when it is in 0 indication, it is in level flight or it is in ground. Here we can see clearly the ground and sea level. We are climbing. Here the indicated blue is the sky and brown is a land. So here we can know the clearly see the descending or ascending or level flight of the aircraft. When the aircraft climbs or descends, the pressure inside the diaphragm changes immediately, but due to the metering action of the restricted passage, the case pressure remains higher or lower for a long time. So, the pressure differential is indicated on the instrument needle as a climb or descent. When a pressure differentiated, it stabilizes at a definite ratio. The needle indicates the rate of altitude change. So, here I hope you have understand something about vertical speed indicator in flight instruments. So, thank you for watching my video, and leave a comment if any, and thank you, and we will see in next video.